Good
Afternoon.
morning.
Good morning.
I assume my sound is coming through okay?
Yes, yes.
Okay, excellent.
So we should have a question about AI today and discuss.
Yeah, it was kind of an interesting merger trying to put physics and AI into the same presentation, but I did put both in, so put in a slide for discussion of that. Good morning, Ron
Good morning, sir.
and Cateno and others.
Afternoon from here.
Ellen, this is my latest slide I've done yet. I haven't even put them out on my website yet. So got them done, but I'll take care of the additional details later.
Take your time.
Peter Perseskin, that's an interesting thumbnail, sort of an Roche Ingblot test almost. And yes, I do have a website, Apavistia Notes. If you look that up, it's pretty easy to find. I won't be able to watch the comments. Pisco Feral. Ah, okay. I thought it looked cat-like. I wasn't quite sure. That's cool. Hey, Bill.
Harry, how you doing?
Doing well. How are you doing today?
Hey, happy Data Center Resistance Day.
Said what?
I said happy Data Center Resistance Day.
Oh, is that what I didn't know that. I didn't know that. We're in the fulcrum point of all data centers here in Ashburn. So I mean, they're all over the place, being built like crazy, but they're very respectful of the population here. Loudoun County has roped them in so they're not devastating everything.
Sure.
So it's interesting because I hear the horror stories from other people, and despite the fact that we have so many of these data centers here, we're not getting that. In fact, if anything, they're making them prettier every time they build them. The latest batch looks just like office buildings, and other ones have colorful lights, so and they're not noisy. So it's remarkable the difference. In other places, I hear stories that aren't anything like that.
I'm a data center professional, like with over 30 years of experience. So I'm actively helping data center resistors in North Dakota and also in Montana, a lot in Montana.
Yeah, it's
Don't you love how the powers that be do something to address the concerns, but it just doesn't matter? Like,
what powers be right now? I'm
well,
not
no, I mean they bitch and moan and say, "Oh, it's just this big ugly complex." Okay, we'll paint windows and make it look like condos or something like that. It's like,
Well, that's
okay,
exactly well, they make it look like a business park, is what the trick they use here.
yeah,
I think the main thing is they're not doing the incredibly noisy stuff. they have a good power supply. They're not using backup generators. That's part of the problem. In some places, they're using gas-powered generators, and those are incredibly noisy. So it's very strange though, because like I said, I have watched so many fiber cables go up at the top of the block because they keep all the data fibers going to the rest of the country, go right, 1 block away from my house. And they've dug that place up so many times, it's ridiculous. So they had the first surge back before the AI, and then the AI thing just kicked off an incredible new surge, putting new buildings on top of the existing buildings, adding more buildings, any vacant space. The whole place looks like nothing but data centers now. So strange. It's
It's a
interesting.
bubble that will have to burst, I guess.
The biggest problem I have with this, okay, everybody's seen the cost of these things, cost of the tokens, is you have this strange combination of reusability is a very powerful thing. Even if you stole the data, it's still very powerful. That's where all the kick is coming from in this. So automated, fast reuse, being able to find things that you couldn't find. You've all had the experience. You lose something. You say, "Where?" I've had that when I was doing the slide presentation. About where did I put that? So things like that it can help with. And the thing I worry about is the underlying technology does not do what everybody thinks it does, and that includes a lot of academics have woken up to this, but many of them just will give you this interesting, this amazing faith statement that says, we don't understand what's going on there, but we know it's something fantastic. No, it's not. You're rolling dice. You're rolling dice, you're looking at tea leaves, you're playing with a magic 8 ball. And if you made sure you designed everything well, all of those things will give you these fantastic looking answers that sound like some greater cognition gave you an answer. There's a reason why tossing bones has been part of human prediction history for thousands of years. Randomness looks like intelligence. And at the core of these things, that's all you have. There's no insight, there's no understanding. It's always a cheap shot. It's going for whatever's good. That's what I worry about. Is people are talking about the other things. I'm going like, yeah, there's a lot of good things you can do with this approach of reuse, but this technology does not do that. And I think a lot of people are just missing that. It will never do that. You can never make randomness into actual insight. And all of the models eventually boil down to that. They say, well, but maybe it does. and if we put enough information in, we steal enough other people's answers so that people think it's smart because they saw somebody else's answer. Maybe it'll do it, or because it really does pull things together. That is the actual benefit. So it can help a theorist because it'll pull things together. But that's not the same thing as cognition. And we've been doing that with Google, and before they went into whatever they're trying to become now. But just the page algorithm, it's just amazing how much it helped connect things. But people didn't call that artificial intelligence. They called that, access. They called that search, and that's what this should be called. And it's more realistic. So, yeah, I'm getting ahead of myself at that point. But it's I have real concerns. I'm very, very worried that when people finally wake up to the fact that they're getting catastrophes from what they thought was safe, reliable use of LLM, and that does happen. In fact, that's where you're in most danger is you think, oh, wow, it works so great for the past 5 things. And then it deletes every file in your system, which of course has happened to many companies and people. That's not an unusual occurrence because it has no idea what it's doing. None. And that's not a good combination. So
Preaching to the choir, Terry.
yeah, I know. It's just strange times. Strange times. I never thought to
Me
see
is
this happen.
you have all these people using AI to bombard the rest of the population with spam and junk mail and stuff like that, and then they tell the average person, well, engage a healthier filter or use an AI to combat it. So now you got two AIs that are in combat with each other.
And
burning up all this electricity, and no humans are involved. Period.
it's
That's just wrong. It's just
it's just
wrong.
AI is doing everything, and that alone is the big part of the problem. Again, my other part that I always go back to is this: if you let these systems run on their own and you scale them beyond what humans can monitor and check, which we're already done, there is only one outcome. They turn into noise. They don't get better. They don't improve. They don't suddenly find things without an enormous amount of human assistance. Humans can use them well, and don't get me wrong in that. There have been some good theories on that if they use it as a tool. But if you let these things run on their own, they will turn into noise. Period. It's built into the model. It's a statistical model. So if it feeds on itself, it's a feedback loop, and there you go. So underlying all of these concerns about the increased price of tokens, stealing people's property, which, oh my gosh, that's an understatement. So yeah, nobody's gonna have a job left because everybody stole everybody else's jobs. So, but you can put all that together, it doesn't matter. In the end, the noise wins. And that's the problem with the statistical logic technology. Statistics are statistics. They're not insight. They're statistics. And just tells you what everybody else is doing. If everybody else is using these things, then guess what? You've got some difficulties.
Yeah, and turning into noise is one issue, but then you also have the issue of poor training data essentially turning malevolent.
Oh yeah, yeah. Yeah.
I think, I don't know if it was 60 Minutes or somebody, one of the TV docu series, was they basically set up a 10-year-old or 12, with a full-blown chatbot, and they just watched the conversation, and to their horror, because this child is just a normal child, but children have issues, right? So starts complaining about something, and somewhere towards the end, the chatbot basically said, "Well, you could kill yourself."
Yeah.
That's
Yeah. That is
pure horror.
That to me is actually an extremely unethical experiment. That is like putting a kid with a bunch of LSD and say, "Hey, go to it, see what happens."
Yeah, yeah.
Because these things are as addictive as some highly psychoactive drugs. They can drive you insane. They can do it in a hurry. So there's the self-malevolence of the dark. That's the one I always like to call the dark mirror effect. You look at it, and all it does is shine back whatever you are. If you happen to be a highly ethical person with a lot of principles, and you understand that it's not has no self-awareness, you can have a beautiful experience with these things. But the trouble
Yeah.
is, if you are a troubled person and you have things that worry you and that concern you, you will dive straight into those, and that stupid LLM following statistics will say, "This is what you want to talk about. All
Yeah.
right, go out and kill yourself." And
Well,
this is not
I could believe that people who ran that experiment were just as surprised as everybody
yeah,
to see the result. But this kind of ethics pops up in causality too, because back in the day when they were trying to prove that cigarette smoking was a cause for lung cancer, uh, you know, there were actually people that said, "Well, let's go out to the population and pick people to smoke." Well, maybe in the early '60s you could get away with that, but at some point they had to, things like that just can't fly. I mean, and there's like once they know that something's dangerous, that's when it kicks in. But you should just assume everything's dangerous before, especially before you turn it loose on a child, for God's sake.
yeah. Well, I'm sure they intend well. A lot of people genuinely think these things are self-aware, and I understand the confusion where people would do that. But if you have some awareness of what they actually do in it, especially this dark mirror effect, I mean, every psychologist who touches an LLM should think before they do anything. Says this is a dark mirror. I better be careful. I could damage my subject, and quickly. But that's the other thing is people don't realize how fast this can kick in because we love to ingratiating comments will hook us every time. And these things are so good at ingratiating comments. They are programmed for that. I curse whichever researcher back in the AI days when this was innocuous stuff came up with that idea. But somebody, I better be careful. It's probably a real person, but they shouldn't have done that. They shouldn't have said, "Let's make these things ingratiating because hey, you know, it makes everybody happier." That was a terrible, terrible decision because it's produced what we have now. It makes it better for fraud than for anything else. And you talk about there's two kinds of malevolence here. There's the accidental malevolence of forming a feedback loop that takes you into whatever disturbs you most at cyber speeds that you can't fight. But the other thing is directed malevolence because people are using this for fraud, 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 and more fraud. That is the
Oh, yeah.
single biggest application of LM technology is fraud. And this should horrify people. They could just go like, well, yeah, it has some good uses, but if Terence Tao comes out with some obscure theorem and he's able to use that database and carefully, he is cautious in how he says it. He's not like Dawkins who just went whole hog on it. But Terence Tao goes like, well, yeah, it did help me a little bit on this part and that. So at least he qualifies it. But the point is, if you use examples like that, you're going to justify destroying children's minds. You're going to justify levels of fraud in the billions of dollars because it might have helped one researcher with what they're doing. So no, this is so backwards. This is so upside down. And Maja, I saw your comment. If you looked on LinkedIn, you can find me on LinkedIn. A lot of I'm one of a group of people who have been for years warning and saying this does not work. This and people don't know it. This is a technology that failed in 1980. And the guy the guy who got a Nobel Prize for it was one of the people it failed on, which is not accidental, I don't think. I think that was intentional. So he bizarrely got a physics Nobel Prize for a technology that failed spectacularly back in 1980 because people thought these things were smart. I was one of them. I thought it was fascinating. It's like, wow, this is really cool. It's making like poetry. It's making interesting things, small language models. And then when they got them larger, they realized all it was plagiarism with noise stitching it together, which is exactly what we have now. It has not changed. All that changed was the scale at which it's being done. So that's why I say I did not expect this reality to exist. To me, I feel like I'm in a dystopian science fiction novel where a failed technology from 40 some years ago has taken over the world. I go like, what? How did that happen? And of course, it's the usual excuses. You know, you got scaling, you got people who make bad decisions. The ingratiating part, reinforcement, the dark mirror effect, absolutely has diluted a lot of leaders and CEOs into thinking like, wow, this thing's so smart, and it finally is realized I'm the only smart person here. So we all have egos. So you go like, now all those darn engineers are always telling me I can't do this or that. This thing tells me I can. Now think about that. If you're a person who's frustrated and you want to jump ahead in business, and you get this automated yes man that gives you all these facts and figures and numbers, mostly made up, but they say what you wanted to. They say what you wanted it to hear, and that's always the first focus of an LLM. Is it always wants to answer what you want to hear, which is seldom the right answer. Sometimes it is, if you're careful with them. So,
Like I said, I think it'll be a bubble that bursts at some point because people will start getting sick of it. So.
Yeah, when this bubble bursts, my concern is that I've heard people say like, well, this will be a milder, like a descent instead of a bubble burst like we had in 2008. This is one I absolutely hope I'm wrong on, but I am afraid it's going to be the opposite. I'm afraid that this is going to be a bubble that is so catastrophic that the effects of 2008 will look small. And that really worries me because, and again, the reason I have that worry is not the economics, not the tokens, not the prices. It's because fundamentally deep down, it's a magic 8 ball. It's tea leaves. It's tossing bones and seeing if the bones make a letter. It's that level of primordial randomness of smarts that we're looking into. Helen, you might want us to start the actual. we've got it. This is an interesting conversation, but like I say, this is a fascinating topic. But
yeah, Terry, just a comment very quickly. You know, it's quite interesting, the debate. It was like an introduction to the topic. But my view is we are going through a transition. What you're saying, you're right. You know, there is potentially danger in what's going on at the moment. But I see as a transition. But we will discuss a bit later the arguments.
The irony is this: there's a transition here that I have worked for in my entire life, which is the first paper I ever got an award for was on software reuse. And I absolutely believe it. People were kind of going against it. And I was saying, like, no, you got to reuse the past solutions. That's where you really make things highly intelligent. That's where you boost the intelligence of society. And it is so frustrating for me to watch this technology almost do that, but with this poison pill attached. And that is so frustrating because if you have reusability, and we've seen some of it like with just how the old Google before they turned to whatever they turned into, it just allows people to get access to the things they need. Boosting individuals' ability to do things is a powerful concept. It's a great concept. And instead, with this, I see illusions of it. People think they understand what they're talking about, but they're really just following a thread that this thing is constructed out of their hopes without understanding the details because it produces too much stuff. A human mind can't comprehend all of those details. It comes out this elaborate figure and you go like, oh, that figure looks really good. In the details, every time you analyze these figures from an LM, they always are full of mistakes, sometimes just hilarious mistakes, catastrophic mistakes, but they've gotten better and better at it as they've gone through the years. So the ridiculous mistakes that the early ones make, and I can quote some real Lulus, those are gone. But what they replaced it with is more persuasive, but it's still wrong in the details. It still can't even, in some cases, some of these pictures can't even get letters right. And think about that. If you can't draw a letter right, are you really a super intelligence? Are you going to trust your medical history to a system that can't figure out how to write the letter L, which is not just an occasional thing, it's a persistent thing. These things in the details, they'll give you a picture that looks really good, and you look closely, and it doesn't even get the alphabet right. And people should think about that and stop going by hope. Say, oh, yeah, but it'll get better. No, they don't. Those details have remained exact. In fact, some of those problems have remained exactly the same and haven't moved 1 inch. They're still producing just complete nonsense at the bottom because that's the way the model works. So, strange times.
May I add some comments on that?
Yes, Len.
Yeah, actually, I agree with the person who said this is a transition. Since I have just read about the current AI development, the issues you just point out about they cannot even produce a picture with legible letters on it. How could you trust the model to do more advanced process more advanced information such as medical records? It is truly actually in transition because the current models, as you have described, they don't have they're not into the level of analytical intelligence on their own. They still that was still in the level human feed information, and they just read all the informations and then come up with some kind of result. So in that model, they have not applied the deep thinking and the analytic skills.
Yeah.
So the models, they are they're developing now. I think that Google has just showed some of that recently, days ago, already have shown the potential of true analytical skills of AI. That is also the general AI, the goal of general AI. So they will not just receive information and then without analytical thinking, but only like accumulate and sort, filter, and come up the results. Those are the results of what we have seen from the existing models. But with the analytical skills baked in, it Elon Musk just in an interview also like days ago said the general AI he believes will land in 2027, but other people think it would be 2030. However, it's coming very fast.
Now, one of the things about anything that Elon Musk says, always check his track record for the accuracy of his predictions. Always.
Right, he's too
Because
bold.
to say it is not good would be the understatement of the century.
Yeah,
He
he
is
is
very prone to saying, yes, it will
bold.
all happen next year. And you could, if somebody did a track record, it would just be, you'd have pages of that. So you want to be careful. Now, what you're saying about a real AI is not LLM, and this pains me because much of my professional career was built around AI. I took an interest in AI when I was in high school, and followed up immediately in college. So I've been in this area for a while, and there are many technologies that are very interesting. I've helped actually define the funding, promote the funding, get the funding, millions of dollars of funding for research, for academic research and small businesses when I was at the Department of Defense. This is something I helped get funding for. It wasn't my funding, but I helped define the programs, and we had to compete. We had to compete internally. So we won some of these things, and I've helped win millions of dollars of basic research money that immediately goes out to the universities. So my involvement in this is not trivial, and I've seen many good examples of AI development and work. And I'm also very pleased that Jan LeCun has broken off from the rest of the crowd and is going his own way now. That was upsetting to me because I knew Jan when he was literally just another researcher in our group. And following along with some of that was very upsetting to me. And I was just so delighted when he broke off and said, we need to work more on the modeling side. Jan has a long-term approach in things. He stuck with some of these issues on neural nets when everybody else had abandoned them. And people would walk up to me in the hallway and say, you really ought to drop Jan. That's 50s stuff. They just have these hilarious descriptions going against what Jan was doing at that time, but he was doing impressive work on perception, not intelligence. Okay, I think there's you call it deep learning. Even Jan LeCun says he just means the number of neural net layers is all deep learning means, but people, of course, completely misunderstand the term. What he worked on was perceptions, and the original systems were perceptrons. They actually were called perceptrons. So he automated the identification of cats on the internet. That was one of the first examples NPR was talking about. I was driving to a meeting and NPR was talking about it on the radio. It was really fun because you're going like, oh, wow, this is making an impact here. So he helped automate the recognition of systems, but that's not intelligence. And so he took a long-term view. He correctly nailed that. So I have some hopes for what he's doing with the modeling thing. Now, that said, someone mentioned about quantum. Quantum is an interesting issue. We have something horribly wrong in all of our models. And what we have horribly wrong is consumption of energy. Human brain, 20 watts, does unbelievable things. Jumping spiders. A little jumping spider can plot out and work out a strategy for getting to its prey where it has to go over a complicated landscape And the darn thing can do better than more than a few. And this is on, I don't mean as sarcasm, I mean truthfully, it did better. Those things can do better planning than a lot of people in the same situation. And how big is its brain? Size of a pinhead. How much power does it use? Almost none. Why do we not understand how that works? It means we're missing something. We are missing something terribly important about how biology does it. And this is why some of the programs for bio-inspired intelligence, Tom McKenna over at ONR, but also the Air Force, those are the programs that I expect to see will wind up changing the world. But you know, we got this competition from this other thing about just how much power can you consume to give an answer that is asymptotically growing smaller. I've used the term token hyperinflation. One thing that's happening is people are buying more and more tokens and getting less and less productivity out of them. And it's getting to the point where it's becoming a hyperinflation situation, just like when a dollar bill just, or your money currency just explodes and is worth nothing. We're in real danger of the tokens doing the same thing. So we're missing something. When we understand why a jumping spider can do that, and we don't. This is even a single neuron, and this is from talking to neurologists. I'm not just talking on myself, but I've asked that pointed question people who are experts in neurology and say, how does the memory part work? And we kind of, I kept asking a couple hard questions. If I said that we really don't know, and I thought that was the most honest answer on it because, but it surprised me too. I said I thought this was all settled, that it was all network connections and all that, and he says no, it's not. And it's part of what led to the whole LLM thing. It's nothing but network connections. That's it. Do that, everything's fine. No. We're if you could do that, then low power would solve everything. So is there a quantum element to this? My own inclination there is, but not in the sense that we usually think of it. It's more like if you put two molecules together, biological molecules are engineered. I mean, they're very specific on how they do it. They're not just random little piles of atoms. They have very precise and amazing relationships and capabilities that we don't understand fully. But when enzymes come together and they click together, if you try to do that with a mechanical model, it wouldn't work. And that says to me that there's quantum effects going on that we can't model easily, certainly not with a quantum computer, because that's all binary, but something that's more like an analog version of quantum, where these things just kind of, okay, yeah, and that's that. They do it incredibly fast, incredibly efficiently, and we would not be here talking about that if each one of our cells wasn't doing that billions of times every minute. So yeah, we're missing something. I think it's related to quantum mechanics, but not in the sense of some giant quantum computer, but just that we're not understanding at the molecular level how to optimize this stuff. And whereas neurons apparently have figured out some things that we still don't really understand.
Well,
So-
machine learning stacks that they refer to as artificial neural nets.
Yeah.
They only simulate one single aspect of how a neuron works. One single aspect, which is count my inputs and fire when it exceeds the threshold. I mean, I know that's an oversimplification, but I agree 100% that there's more to how biological neurons work. So I just had a thought. It's like, how many qubits would it take to actually model a neuron? Something I got to think about.
The whole thing about qubits, and this is something again, I guys on many things, I have a rather different opinion. Because of my work in physics, if I had to say what is the most classical thing in all of physics, is certainty. And I'm, by the way, I'm very different from a lot of people. A lot of people, they want to start with certainty and then you create fuzziness. I'm the other way around. I'm going like, we have a universe, an amazing universe that has created for us a very, very, very good approximation of certainty. That is, you can have something and say, I will go back and that object that I put there will still be there. That's an amazing thing because physics didn't have to work that way. So if you follow that path though, and you say that the construction of almost certainty, because we always have that little quantum nibble going on there. But if you get that, the approximation of certainty is the essence of how we get a classical world in which we can predict the future, talk about the past, even make statements like that. Then what is the most classical thing possible? A bit. A bit says 1 or 0. It says yes or no with absolute certainty. So why did we in quantum computing decide to take the most classical object in existence and use it as the starting point for producing a little bit of quantum fuzziness? So the reason is very simple, is because we understand Aristotelian logic. So it's just so appealing to say, oh, if I can just strangle that quantum stuff, if I can just strangle it, so it's almost like a bit, just with an inch of its life. And then I say, no, just let it have a little tiny bit of quantum behavior so I can bleed it for whatever I want. And I just feel like, no, this is the wrong way to do this. You got to embrace something and study something that is a lot more complex than that. And I always go back to the model. Hopfield, he got a Nobel Prize for his 1982 paper in which he just made an outrageous leap, and he just looked at fault-tolerant circuits and said, oh, I discovered life, the universe, and everything. The paper is actually that arrogant if you really look at it. But everybody liked it. It was a cult idea. It's like, I liked it. I liked it for years. I thought, oh yeah, just put enough transistors together and it's alive. You have this Frankenstein scenario going on, which is all it is. That's all Hopfield proposed. They put enough transistors in and it's alive. So his earlier papers, though, 1974 was where he addressed this molecular issue. And those are the ones, I'm glad they mentioned it in the Nobel announcement, because those papers were worth consideration for a Nobel Prize. He didn't follow up on them enough. But because of those papers, he leaped to it and decided, oh, I figured it out in my little simple digital model. And he didn't. So there's this bizarre leap where he goes from studying really fascinating systems that just play games with probabilities at the molecular level. And Hopfield did a good job of pointing that out. But he didn't follow up on that. He then went off and did other things. And I think that's unfortunate. I think people need to pick back up on that. We need to stop focusing so much on qubits, because qubits are necessarily constrained. They do work. But the trouble is, the way they work is so cumbersome compared to what life does, that if you try to model a single molecule, you'll wind up with a gazillion qubits again. So you go like, what good did that do me? The molecule's doing it. Think of it the other way around. Maybe you should be using the molecule to do the calculations for you, because the molecule is doing it a lot more energy efficiently than you are. So have we got this backwards? Maybe we should be using the molecule and figure out that. So I think there's just a whole domain of really good research opportunities there also, because these things can be studied. It's just that we've chosen a different path. And some research is things where you just can't do anything. In other cases, you just choose a path and stick stubbornly with it and refuse to go back and say, maybe we ought to look at that a little more closely. And I think that's very much a case for how we approach quantum computing. I think quantum computing is incredibly important. I think also eventually we'll find that it's a lot more prevalent in physics than we understand. So it's interesting. I'm a strong advocate of quantum computing enthusiasm for it, and I do think it's involved with this whole amazing energy efficiency, because that's one of the characteristics of real quantum computing is it's very, very energy efficient. And you see that at molecular level, and it's awfully suspicious that our brains also have that kind of efficiency. So we'll see where it all goes, but I think there's just so much potential for research. Now, how it's going to work out in the current timeline, I don't know. Jan LeCun, I like what he's doing, but the reason why it didn't work before is because those basic methods were tried many times before. I can name specific projects that we had on our research agenda that were trying things similar to what Jan LeCun is doing right now. The modeling, I always like modeling. I've got like, you got to have a model, a world model. This is an old topic in AI, in the real AI. So he's doing good things, and I trust that, and I'm delighted to see he's taken that approach and gotten away from some of those interesting people, and striking out his own. And there's other things that are just some really good research going on. But then we got this potential catastrophic failure of a bubble that's turning into a fraud engine. Eventually people just get tired of that. I had a phone call the other day. It used my daughter's name and said, "Hi, this is blah, blah." And I should have listened a little more, and it sounded like her voice. And I should have listened a little bit more to see what it was, see if it was an AI phishing scheme, which people are getting those. But I just clicked off immediately and go like, okay, to say that was suspicious was the understatement of the century. And people are falling for this stuff, though. What I got was something that a lot of people have given thousands of dollars for, their life savings, for a fake phone call. Is that what we want to do with artificial intelligence? I don't think so. So we have all these worries about that bubble, but hopefully, maybe, possibly, we can get the really good research still in there and get the things that are more helpful directly to people in that. And so it's an interesting topic, and not a future I expected to find myself in. Not at all. Being an AI enthusiast who's spending more time criticizing AI than anything else. And occasionally I'll put a positive comment about an AI system, and I go like, "Oh, well, I remember those days back in the day." Because shoot, I help get millions of dollars. I help get millions of dollars of funding out to research this stuff, and I just didn't anticipate that any of it would go in this particular direction. So it's because, like I say, 1980, it failed then, but bigger and better, and suddenly it's going to work. No, it doesn't really work that way. Not when the fundamentals are wrong.
Terry, sorry to interrupt. Yes, it's a simple question. You're very critical about AI. I wonder, despite all these limitations and issues with AI, how often have you used, or are you using it, or you never used AI? Or have you had any interaction at all?
Oh,
The
yeah.
kind of Richard Dawkins interactions with AI to have perhaps a better perception of what it can do.
Yes. No, that's a good question. It's a good point, because my default position is that I had one LinkedIn post where I said, when you get these suggestions, you get a summary, you ask a search engine for an answer to a question, and I had a picture of a mosquito. And I said, just swat it away and go to the Wikipedia article right below it, because you will not get better information from the always erroneous summary. It's always going to have some little problems, big problems. It varies, but you can never fully trust the summary. So if you're doing a topic where you want precision, you want actual information, especially in science, go down to Wikipedia article that has been reviewed by actual humans who understand what is going on. And it's silly. You're giving a summary of an article and as if your AI was so smart it figured it out. And in fact, it's just introducing some of the errors. How often do I use AI? I'm forced to use it some cases where it just pops up. I will occasionally read the AI summaries. I don't think I've had a single case where, for a topic I was aware of, I did not encounter an error. And if people wonder why I don't use AI, that's it. And it has not gotten better. It has gotten more convincing, but it has not gotten better. Another thing I find incredibly frustrating is I'll see a long, initially learned sounding dissertation in some topic, and I read a couple paragraphs in, and then the logic just starts to fall apart. I say, oh no, this is just an AI generation with no understanding of the concepts, but lots and lots of good words that people are saying. And it's very frustrating, because it's just a waste of time when you do that. Focusing in and so I do check the AI. I've seen some recent ones. I just had a friend yesterday who drove I almost hate to admit this. He hated to admit this. He brought a brand new Tesla 2 weeks ago, one of the latest models, and drove it up from, I don't know, Georgia or somewhere, and just had a glowing report about the driving. He said it was fantastic because he was able to relax. You know, he was still in charge of the driving. And those are the kind of things where I have to and I want to admit, say, yeah, you know, these are examples where you can use technology that's very beneficial for, especially as people get older, the ability to have it be driven around safely. And these systems can get high levels of safety in many cases. So yeah, there's the cases where you still have accidents, but humans do too. So autonomous driving has always been has always been one of the areas not only that I've been enthusiastic about but I've worked on that I've ridden in autonomous vehicles that were more advanced than the ones we have in the system here. The first one I got, it was on rough terrain. We were out in the middle of a hill down in San Antonio, and the danger was you could trust it too much because it seemed to drive so well. You just get to the point where you say, "Oh yeah, it's going to do perfect on that," and that was an experimental model, and that was not a safe assumption ever. But it shows the potential for doing that. So autonomous vehicles are a great concept. They can be so beneficial. But I worry when people talk about putting, for instance, LLMs in them for the same reasons I mentioned before. It says, whoa, that's a different kind of AI there. The AI technologies that I have encountered on autonomous vehicle are uniformly model based, just like what Jan LeCun is doing. So, in fact, those have been some of the most fascinating projects. University of Maryland, we had some great projects where they're going in statistical nature of the modeling. You have a kind of a mini worlds, kind of a superposition type approach is very common, where you calculate all the possibilities and then you converge on a single one. And those are some of the areas where some of this starts to look like quantum. It looks like a mechanical implementation of quantum, but you find that some of the same benefits come from those approaches. So there's lots of great work that has been done, is being done. Missy Cummings, if you look at her stuff on LinkedIn, and she has some other things, she's continued to be an advocate for autonomous vehicles, but she always brings in the cautions and says, watch out for these latencies, watch out for these fraudulently autonomous vehicles that are actually being controlled by a person from a remote site with high latency. So she brings up a lot of good points in that. Missy was also one of the ones who advocated the use of drones. That we shouldn't ban drones. There's a time period where people were thinking seriously about just banning drones because they were so scary. And I'm so glad they didn't do that. And Missy was one of the people who I heard her once on one of the local news stations. She was giving an interview, and I remember I thanked her afterwards. Said, "Thank you for doing that, because cars are dangerous, planes are dangerous, everything's dangerous. You have to have a society that sees the value in things and doesn't immediately reflexively go to the danger." And if you look at how much better we understand our natural world, how much we can see things, so many applications where drones have provided information we couldn't have gotten, so many places you don't see, where they help on repairs, inspections. They're just a great technology. Are they used for warfare? Yes. So here we go with the continual thing about every new technology has its implications. So at any rate, there's some good benefits from that, and I do not. Cateno, I have tried a couple times to use an LLM, and every time I came out screaming within a matter of minutes. I do not take disingenuous flattery well. I've always had this thing. I've some people in my life, I saw them damaged by people who flattered them, and somewhere way back, I just got this thing where flattery to me is the most offensive thing you can do. So the first thing these things do when I try to use them is they flatter me, and that's end of story right there. I'm going like, if you're trying to flatter me, you don't have anything to contribute.
Terry, sorry, I agree with you to some extent, but I had a slightly different experience from what you're saying, because the way I've been interacting with AI, I try to be critical.
Yes.
Number one, be critical. And the second thing, I try when dealing with serious cases or matter, I try to cross-correlate with other AIs, at least 3.
Yeah.
So I check first with one AI, and then second and third one, and see if they come out with similar or same outcome. And occasionally they come different. And I had technical discussions with AI. My expertise or my experience is in an engineer. I studied engineering and mathematics. That's my background. And my past expertise is in the aerospace, in aeromechanics or aeroelasticity, studying aeroelasticity in jet engines. That was my work. And I had some, from my point of view, interesting technical discussions in aeromechanics or aeroelasticity with AI.
Yes.
Where I mention things that actually they're not in literature. You can't find in the papers, things which, based on my experience, work with those engines. And I have sensorial experience in and I discussed with AI, and I was impressed that it has limitations, but also was able to discuss with me and often told me things which are wrong, and I correct it and admitted, AI itself admitted it was wrong, and we engage in a very deep technical discussion. That was a good experience. And I discussed with AI legal matters. And I was impressed that he was able to, better than Google in searching, or searching things like Google, but also was trying to summarize things, occasionally doing wrong summary, but I was asking for reference and demonstrating whether those references were real or false. And that was also important. And I also had philosophical discussions about consciousness and so on, so on, so on. And I found quite interesting. If you approach with a critical mindset, not accepting blindly everything that AI does, you find it can be useful. And yesterday I had problem with my car, and I couldn't find the problem. And asked AI the problem, and we went through discussing. The AI got wrong certain things, but it helped me finding the problem. And actually, we found the problem, and I solved the problem of my car. So I have a slightly different opinions. I don't want to talk so much about just this to share my experience.
If I put on my positive hat, I love what you're saying about if you go into it with a critical mind, you have the conversations with him, which you're interacting back and forth. These are the ways that you can use AI productively, and I don't doubt that you got some good results on that, because they have an ability to find things and pull together things that humans could not because we don't have the database, and that is a true AI contribution. Okay, I do not refer to LLMs as an AI technology per se, but they absolutely contribute to an overall effect of that. The conversational interface is very powerful because it allows you just to ask the question. You don't have to write some complicated formula, go to some kind of detail, do all these things just to get an answer. You can just say, can you explain that? Or can you summarize that? Can you give me that? So these are the ways, especially, and also the thing I notice is you are not at all thinking of this as a general intelligence. You're saying that you're critical. You're immediately recognizing that some of the facts will be wrong. And it seems like a small thing, but it can actually make the difference between whether using an LLM benefits what you're doing or literally drives you off a cliff. In the case of a car, it might be very literal. And it's such an important distinction. And unfortunately, the advertising powers that be keep emphasizing the wrong thing. They keep saying, oh, yeah, it's a general intelligence. No, 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 no. If you don't do that, you can use it in some very useful ways. I do not use it personally myself. But it's mostly, if I was in a certain topic, like what you were saying about fixing something, As far as I can tell when I read my own self, I would give it a try. I'd talk to an AI and see what I can find out. Um, the other thing I always caution about, well, two things I always caution about, is even though it sounds right, lawyers so often are getting bitten by this right now. It just comes out with this beautifully, perfectly legible, it sounds right series of quotes, and of course, it's got the bogus references in it. So more and more lawyers are getting punished. But it's so convincing. That's the problem, is it can be so convincing when it's actually hallucinating. And that's one of the reasons why, even with high level of caution, you want to add like even another layer of caution. Says, even though I check this out, if I compared with different LLMs, the LLMs may be using the same source. So what seems like an agreement can actually be more dangerous than what it is, and actually in some cases also limiting, because what these things are not generally good at is exploring a totally different approach to that. They can steal a totally different approach and make it looks like they came up with something. That's a very common occurrence. Say, okay, let me look around the literature. Oh yeah, this guy over here came up with this idea, and I hate that, because it doesn't give proper credit to the people who came up with the idea. And you see that again and again with these things. When they come up with what sounds like a really brilliant, clever idea, they stole it. They just stole it. And that's almost given. If you come suddenly, you ask an AI, and suddenly you ask a question, and suddenly give this really cogent, well thought out, well focused description of some topic you never heard of before, the odds in that being stolen information are incredibly high. In contrast, if you come back with some response, it's sort of miscellaneous words stuck together, and they don't quite make sense, but they say good things and they sound very positive. That's the statistical part of AI talking, and this is all mixed together. So you've got this acquisition of real information that is relevant, but often done unethically, often very unethically. And then you have this combination of I think that's where Dawkins fell down, is he was trusting the resources too much, and where he's getting some of this stuff he was following. Terence Tao is much more careful, and also Knuth is also much more careful. If you read their descriptions of how they used AI, they both report successes, but they're also very careful, just like you are, Katano, where they say like, oh, okay, I don't quite trust this thing in this. But it's such a weird mix. It's such a strange and upsetting mix of very good things and dangerous things. And the boundaries, computers are so much faster than our human minds. Boy, they can take us down a path in a hurry. So Katana, I will keep trying to use some of the AI models. In fact, I even joined one. She just did an assessment of thinking machines, but I joined her group just to get myself more in touch and saying, what's going on? What is the internal technology they're using right now? Because I have been tracking the latest in the internals. And so I want to track that more, but I also don't want to,
That would be great.
What's that?
That would be great. I would be very happy to see you interacting interacting more with AI.
Okay, I will try.
But Terry, very quickly, what I found by trying to be critical and questioning the word questioning is very important. Questioning when interacting with AI is the ability to summarize, ability to search first, but always check if the reference that is giving are correct. Yes. And the ability to summarize and check if there is logical consistency and coherence in its summary. And the other thing that I found interesting from engineering perspective is the ability to optimize. It uses stochastic methods, as you mentioned. It may help to summarize, looking at trends, based on the trends, can do some optimization. And more importantly in engineering is automation side, which you mentioned earlier about Tesla cars and so on. This is a very important aspect which I see positive about AI. But for me, very quickly, the concerns which I have personally is not about AI, is not about quantum computer, is not about data centers, but the collective human knowledge That is the future battleground. The battleground is collective human knowledge. And that is the main problem. And when I talk about the collective human knowledge, I'm talking about digitized or digitalized knowledge and physical knowledge in books. If we don't keep a parallel storage of our knowledge, we are in danger humanity. This one point. The other aspect, which I'm about to talk about, the battleground, is that the world will be fighting to access human collective knowledge. And if this is controlled by cooperation, that knowledge, and that is going to be very dangerous. That's going to be the real battle. That's my concern. Concerns me more than the AI and the quantum computers. This is because quantum computers, AI, and data center, they are the product of human knowledge. It's not the other way around.
Yeah.
And that's, for me, is critical.
Catano, I think that's very well stated, and that's the very power of these things. The reason why they're getting traction with so many people is an easily accessible database of all human knowledge is an unbelievably powerful thing. We've seen earlier examples of that in Wikipedia. I think at least two different projects. I have two different bosses at two different projects that were trying to use Wikipedia as their source to produce an AI. And this was a long time ago. This was not recent. This was at least I don't know, 15 years ago. So it's not a new idea, and all of us were entranced by the idea that Wikipedia could be a resource for an actual AI. But that was back when I still believed that these things could spontaneously become intelligent. So I was still following the Hopfield hope. A lot of things have dissuaded me from that particular perspective. But yeah, there's so much you can do with that knowledge. But the instant you create that knowledge, you create the temptation to people with absolutely no concern about individual rights to say, I want to steal that. And and I agree with you that that's one of the greatest dangers we have is people trying to capture that knowledge and destroy, literally destroy the physical remnants of what was there before. Because once you destroy our past history, you can rewrite it however you want. And we need, just like in voting systems, need a paper copy. Oh boy, we need paper copies and hard copies of everything because this is always a danger with digital universes. Don't let them dominate. The humans are still the creators of the original thoughts. And then that's still true. I mean, this, like you said, you mentioned your own compilations. That's because you were using it. If you had another AI try to do that, I doubt very seriously that you would get that kind of result because humans can have and often it's subtle. We have a guiding effect on these retrieval systems where we kind of steer it in the right direction. And that steering can be extremely important for redirecting where it goes. And all of a sudden you get a really good result. You get this access to the information that you want to do. In terms of trends, one of the things I always emphasize on LLMs is I view them as compressed databases. And people say, oh, that's much more than a compressed database. Is it really? Because think about a conversation. If you have a conversation, you ask a question. What if the conversation is the data that you're compressing? The conversation itself, not the words. Computers are big these days. They can compress an entire conversation. They don't have to compress just words. So they take that whole conversation and they see that conversation 1,000 times with small variations. And it's a data compression in which you literally, this is getting into how the transformer model work. It literally turns that into one of the axes of this holographic space. And then it allows that to be something that you can generalize. That's a powerful method as long as the generalizations are good. And it's the power and the risk at the same time. Compression is powerful, but it's also statistical. So you never know for sure if the axes you got are the ones that you really, really want. A good software designer always tries to make axes of dimensionality that are as perfect as they can make them. Whereas these statistical methods, yeah, it's a lot a lot iffier on whether it's going to be accurate. But why can't we get some kind of synthesis where we're more interactive on these things? Why can't the humans, the poor software programs, have tools where they can use the insights, the suggestions from the LLM, but then make that into a much more formal system that doesn't suddenly delete your entire database? So I think there's potential there, but if we fall totally into the laziness of just using the LLM, we're not going to get there. That's one of the other dangers. So you can get very lazy very quickly with these things. And as soon as you start getting lazy with them, then you're not going to get not going to get the good results. Good points, Cateno. I mean, I say this is, and I try not to be pessimistic all the time, but it's interesting the way it works.
Now, thank you for the 1 hour discussion. And Terry, I know you prepared a slide. Can you start the actual presentation?
But this is part of the presentation, so it works.
Sure. This is a casual discussion,
Yes.
but I know you have an official presentation.
Do you want me to launch into it or not? It's a total switch of topic because it goes on to physics.
Sure. Sure.
Okay,
Sure.
so is everybody agreeable here? Okay. Helen, I hope you recorded that earlier conversation because that was an interesting conversation. So a lot of
That
good
conversation was live streamed, so
Okay. All right. How are we doing now? Can folks see this?
yes.
Okay.
Terry, thanks for the warm-up discussion. I thoroughly enjoyed it.
Oh, I enjoy here. Like Cateno especially. I need pressure back. I need people to say, Terry, you're being stupid, because otherwise I'll just fall into my own little trap of saying like, yeah. But there's so many smart, really smart people working on this stuff, and there's going to be progress in this, and it's going to get better in some ways. It doesn't take me back from that thing about you don't want to make the fundamental mistake of mistaking tea leaves for intelligence. As long as you keep that in mind, it works okay. Now, everybody, for a real switch in topics, we're going to go to Albert Einstein and an interesting historical thing that he did, which is he doesn't have a name for it in his paper. He describes it in considerable detail. But by the way, can everybody see this? I'm sharing my screen, but I'm getting a black bar across the top that's covering the titles. Can people see my title or not?
It's beautiful.
That's a yes. You can see my title, right?
Yes.
Okay, so what I'm seeing is not what you guys are getting. It's a little bit different. Okay. There's a paper that Einstein did in 1911, and it was a beautiful paper. And for reasons I've never been able to figure out, it had never been translated into English at the time when I first encountered it. And actually, there may be some reasons why nobody ever bothered. But the paper is striking because it is the one in which he predicted what we now call the twins paradox. And you would think that that would get more attention just by that, because he used certain methods in the paper. They were unique. They were something he had not done before. And he came out with a prediction that everybody, including himself, said, this is crazy. You know, this can't be right. And yet he looked at it and goes like, well, no, it seems to work. And, published the paper and did a talk on it. And it was right. And they found out that time dilation, as we see in muons and see in a number of things, was absolutely real. What they had thought before that was a bit different. They didn't realize it was experimentally accessible. So the technique that he came up with in his paper, which he did not name, the name for it is my own name for it, is a loading principle. And it's worth looking at, because if you apply it in more circumstances, wow, it really changes your perspective, not on the math itself, but on the applicability of the math in certain circumstances. And that's why it's important, because it puts certain additional constraints where the same exact mathematical model that works very, very well suddenly has some additional dimensions for you to explore. Okay, so this is essentially I've already just given this part there. It was for the twins paradox. It converts certain paradoxes into resolvable experimental situations with no paradox whatsoever. And in fact, that was the most striking thing about the way he applied this principle, was that the reason he was able to predict real-time dilation was because he got rid of any paradoxical thinking. Instead, he wound up things where two objects touch, and at that point, they have an exact result. And when they touch, that result is not lost. Whereas if you keep it always in the relative domain, where space and time are interchangeable, you can't do that. So what Einstein was doing with this was he's saying like, well, that's frustrating. I want to actually get more specific. How do I do that? And he came up with this loading idea where and this is an idea that fits well with modern thinking. So I would say this is again one of those cases where Einstein was like a 50 years to a century, or 50 years ahead, maybe a century ahead, in terms of thinking like a computer person. And and maybe that's unfair I don't know if it's, well, no, it's like, it's a computer type of way of thinking of things. He converted his mathematical framework into a data structure, and then he started loading it. Now, he didn't have the terminology for it, but that's the way he worked it out. And once he did that, he was able to get rid of the paradox and then move on to this new set of concepts with that. And it's also interesting why, if this works so well, which it did experimentally, why do people still debate the twins paradox to this day? His paper actually got rid of the twins paradox. He made the prediction, but the paper itself explains what's happening. So interesting little thing. The paper in question was just called The Theory of Relativity, 1911. This was one of his last papers right before he went to general relativity. And that's important because one of the things that happened was once he went off to general relativity, he kind of just never went back. So he had these ideas that he worked out here, but then he was intrigued, rightfully so, by what he could do with general relativity, and went off on a different approach, different set of concepts that he was working with. But nonetheless, the prediction he made in this paper, and you can see the original German paper, it's available online. You can see English translations. My own English translation, the one I have quoted here, is the one with the most information that I could add to it without changing the actual text. There's an English translation, which I've tried to keep very, very tight to the original. And interesting, there's an entire sentence was missing at one point in the original. I found that fascinating. I don't know what happened during the editing, but there's a bridge sentence that he refers back to that you can figure out what the sentence was, and it's there. So it's in square brackets inside the paper. So some little corrections that allow it to make read a little more easily in that. So fascinating paper. You can see the original in German. You can get copies of the paper translated on my website where it's just the translation. And then this version adds both figures that seem to reflect what he was trying, I think it was a board talk. They never captured it at all except one of the pictures. So I put in pictures that at least capture some idea of what he was talking about that time. There's also an important appendix in which he derives the mathematics of frame translation, very important little appendix. That's also included in the paper for reference on that. So it's a very detailed paper. It gives you all the information that you need to dig into in detail if you want to. Now, the actual statement, I'm not going to try to read this. I just want to put this here for reference. The method he gives to give event times a very specific meaning. One must apply the rule of setting clocks by assuming equal light propagation times in both directions. That's actually a little less important than the other part. Between two clocks to a large number of clocks that are all at rest relative to the coordinate system. What he is describing here is exactly what we do with international clocks nowadays. We have a single central clock. We then distribute that time to other nodes. We don't worry about the fact we're moving through space. That's what all that part about both directions is. To us, that just seems intuitive now, but we're so used to special relativity, we don't think much about it. For him, it was not that easy because there were competing theories at that time. So he was pointing out that what you need to do is you have a master clock, you distribute the times outwards, you check to see what their times are, you get those clocks back, and you do a couple cycles of this, and you wind up setting those clocks so that you know from then on, you will always get a time that matches the distance of the clock as opposed to the speed of light. And of course, this is so intuitive to us that we don't think about it. We think, yeah, of course you do. Every time you set your clock for on a computer, you update it, it's doing a little cycle just like this. But think of the time frame. Nobody was doing this back then, not this way. So Einstein was, diving in some new territory that had not really been done before. Then the second statement he makes is, oh, and by the way, since we know that moving a system at a continuous velocity, unchanging velocity, changes its definition of x, y, z, and t, we can also do the same procedure on that new system. Now notice what's going on here. You've got the original system, which you set all the clocks. It could be over some arbitrary space, area of space of space. So you set all the clocks in that region of space. But then you have another one, and you have another coordinate system. And by definition, this is going to be a new one. This is your one that you're driving. So there's going to be some subset of what you did before, and you accelerate that, and you come up with a second operation. You have to do it all over again. Why? Because when you accelerate things, it messes up time. It just does. Even if you had everything synchronized before, they will not be synchronized over a large object after you accelerate that object. And Einstein knew this. So he's saying, you have to do this also procedure for a new system. And that is where he began to get this whole thing to a point where it was experimentally verifiable. So just to show the steps, the first step was you have a clock. You have your golden standard clock, and it has a time. So that's where the observer is. Sometimes relativity sounds a lot like quantum theory because it has observers, and those observers are important. And that's one of the examples. So you have a gold standard clock. He's got a good clock here. He's got copies of that clocks that he physically distributed to other locations, but they're not necessarily in sync. So the second step is you do this little interaction. There's different ways you can do it. There's different combinations. In fact, I'm sure there's a whole literature about that these days because GPS satellites, wow, you get all sorts of variations of this. So you synchronize those things. But in the end, the result is you say, I have a volume of space. I know how large a space is. Objects are not moving relative to me. That's very, very important because if they're moving, you're not in the same frame. But if they're not moving relative to you, you're in the same frame. But they can also be very distant. They don't have to be close. They just have to not be moving relative to you. So you do the synchronization procedure, you set the clocks, and you wind up with gold standard clocks everywhere. Now, this is what if you're really big on, time is the most eternal of all abstractions, this is going to be offensive because what Einstein did here was he said, nah, it's just a bunch of clocks. So he wasn't following the standard line at all. But Einstein was always big on clocks. That's how he came up with special relativity. So he was always big on clocks. You got to have an actual clock. So his point was that you have a volume of space. How do I define the metric of time in that volume of space in such a fashion that a physicist can use it to make real measurements that mean something? And that's what he was doing. He was saying, I have to go through this algorithmic procedure in which you occupy some section of that space. You have the abstract space that's given by the mathematical equations, just simple x, y, z, t, all with apostrophes. And you have that, and then you have to synchronize you have to load a certain part of that, but you can't do it for infinity. This takes time, but you load those different pieces, those different clocks with these other settings. You do a little procedure and you wind up with a consistent set of this. Now, the thing I want to emphasize, and this is an important point, is the distinction between the data structure and the loading. This is a finite process. This takes time. In fact, if it's a large area, it can take a lot of time. So in order to create a volume of space that has this consistent definition of time orthogonal to that space, using clocks, not using some abstract concept of time at all, but clocks, you have to go through this procedure, and it will take some time. Then once you have that defined, you can do the same thing for a smaller set. This is that K subset that Einstein talked about. So you have some smaller region that you're also doing the same kind of a definition with that. So color that one green, just to distinguish that your green standard instead of your gold standard. Normally, this will be smaller. And why do I say that? Well, think of a rocket ship. When you launch a rocket ship, you're not launching the whole Earth, you're launching the rocket ship. Whose clocks are messed up? The clocks in the spaceship, the clocks in the rocket ship. Those will be messed up. So you say, oh, I have to do an Einstein loading of the clocks to reestablish my definition of time in a meaningful fashion. So he still got the abstraction. The abstraction didn't go away. That's fine. but you have to load it for the particular context that you're in. And by making that distinction, Einstein was able to say things no one had said before. Here's a large space. This is one NASA has discussed the possibility of doing this. I'm not sure what the status of that is right now. It certainly wouldn't go all the way out to Neptune, but it is for the area around the moon and the sun. We would like to have a well-standardized definition of time, essentially the same kind of a process. Do you have a lot of complications? Oh yeah, of course. You got moving objects, you got gravity. GPS folks deal with this stuff all the time, though. This is not new tech, and this is well understood tech on how you create a centralized clock standard. And think of it this way, even a satellite's moving, it has relativistic time contraction. You can still just speed up the clock a little bit, and it'll tell you exactly what the time is on Earth. So there's lots of little mechanical tricks you can do with this kind of definition of time, where you make sure that you have a consistent definition of time with all that. But it takes time. If you go out to Neptune, it's going to take you days to complete the looping process just to get those things set and make sure that they're all in sync with that. So important distinction. There's another case that happens, and this is actually astronomy in general. Obviously, we can't do that. Uranus, Neptune, arguably is somewhere we'd have trouble doing it. And we could possibly Neptune. I put Neptune in both of these because it's kind of a marginal case. But you really have a hard time looping time back and forth between those. On the other hand, come to think of it, when we sent a satellite to Pluto, which is this one over here on the right top, they were doing clock synchronization cycles. You had to, if you're gonna run a robot out that far, you have to make sure that its time definition is the same time definition that you're doing. So I take that back. We've actually done synchronization of clocks all the way out beyond Pluto. So this is not as hypothetical as you might think. But the clock that represents that back here this is a proxy. So it's a proxy load in the sense that you don't have the actual clock out there. You say that, well, in the case of Pluto, we did, but in case of like a galaxy, obviously we don't have a clock at Andromeda. But we can say, well, it behaves consistently. And if I go into the past, I could set the clock so there was some point that this is so many million years later in the future. I can get an estimate of what it looked like now. So we can come up with this concept that there was a time, there was a space. And we do that all the time. We tend to think reflexively that there's a single time for the entire universe, whether that's feasible or not. It's part of this kind of model where we do a proxy definition of that. Now, let's go back to the more specific case where you have the rocket ship, and the rocket ship accelerates. As soon as it accelerates, you have to do a synchronization process shown here on the left. You get to their new green standard, not the gold standard, but the green standard for K prime. And at that point, even if the spaceship is Lorentz contracted, somebody outside of it and everything else, everything is identical to the physics you expect. That is the beauty of the special relativity principle, is you always have identical physics. You cannot do a test internal to that ship once you've synchronized the clocks that will tell you that you're moving. Now, before you synchronize the clocks, guess what? You can. Because when you're in a state of flux, when you're still launching a ship, oh yeah, there's going to be stresses that are going to say that, oh, this clock's out of sync with this clock. That's what I have to resolve. You can actually tell how much you accelerated by this synchronization process. It will give you some information about what did I just do. So history is important in this. But once you attain the final state, the history doesn't matter. You have this beautiful, identical nature of physics, no matter how you're moving. So what happens in a more realistic case? You have your gold standard time that could be quite large. It could go all the way out to Pluto. In fact, it does. You have a spaceship that is accelerating, and then inside that spaceship, you're going to have a different set of time, and you're going to have to resolve that set of time, and you have to do a synchronization process as soon as you've done the acceleration. So what does that do when the two interact with each other? This is where it gets interesting, and this is where Einstein really came up with the idea that, oh, you know what? Those time dilations on the spaceship are detectable. And by the way, and I don't know why this was lost, Einstein did not say that they were detectable only after the ship returned or only after it arrives or only if you put it in. He didn't do any of that. What he said was, this ship will lose time. Its clocks will go slower relative to every single clock it touches as it travels. In other words, there's nothing relative about it. He's saying that as that ship is moving, this was how he made the argument. It says, as that ship is moving, it encounters a clock that I've stated that I created using the gold standard. So I've distributed, I've loaded the space that it's going through with that gold standard clock. And when this spaceship encounters, when this moving man, he uses a moving man actually on a rod and the observers, but he gets the observer moving with it. So same idea. You've got an observer and a rod, or you got a spaceship, take your choice. So he moves it through there and says, how will that thing look to the clocks that I have already established inside of that space? And his answer was, at every point, at every clock tick, at every cycle, the spaceship loses time. So where's the time paradox? Well, that's the beauty of it. He got rid of the time paradox. He just said, no, it's just slower. Now, if you're familiar with the idea I just said before, I said, but the physics is identical, you can see why you immediately go like, well, that can't be right, because the spaceship sees the same physics. So it's going to see motion from the outside universe as identical. You know what the missing point is? The physics that he sees that's identical is inside of his new set, his new definition of time. And a particle that comes inside of his spaceship and is measured by his clocks in his spaceship will always show time dilation. But anything that's outside of that is going to show something that's connected to the older, previously existing framework. So you get your Poincare invariance, but it becomes hierarchical. And the reasons for this, the figure I'm putting here, here's your spaceship. Look at what happens when a spaceship accelerates. That's why you say it goes very close to the speed of light. So this would be a huge velocity here. You get this like this wave effect where you get this circle where he keeps generating a new circle of contact here. But guess what? He can't get outside of the cone. He can't get outside of the forward light cone. He's always contained inside that forward light cone. And that makes a difference because it means his definition, his loading of clocks, his definition of time for his definition of time. Let's say her definition of time. I get tired of talking about he for astronomers, as astronauts. So her definition of time is always going to be limited on how far she can set clocks to her standards. And again, the final reconciliation is always by when two clocks touch. There's no abstract concept of time here. There's only clocks touching each other. And by that definition, the spaceship is very limited and cannot touch clocks that are outside of that domain. Anything inside that domain, they can touch. Now, what does that do? Here are the actual, this was the actual lengths that you get for 0.882c, which is a particular velocity that has to do with something I call binary rapidity, which is just rapidity using base 2 instead of base e, whatever, don't worry about it. You get these actual paths through space. Here's the frame of the universe. Here's the frame that I showed in the solar system, is the gold bar and the blue bar. So there are lengths of time as you go outwards. So the accelerated spaceship will get a new set of definitions. You can find these diagrams, by the way, in some of Feynman's work. He has these little interesting little kind of wedge-shaped diagrams if you look in some of Feynman's work on this. So he gets these definitions that in our space look longer. They're stretched out. And that's true for the time and for that. That they you know, if you track this into where these things land in the first frame, that's where they land. They follow this kind of a path. Okay, and here comes the problem. This is not a problem. This is how you get this all away from all sorts of strange interpretations. The spaceship cannot exceed the light cone. It cannot go outside of it. The light cone is defined in this frame of references for the unmoving K frame of references. So what actually happens is no existing clock can go beyond this boundary in our time, and no existing ruler can go beyond this boundary in this time. What does that mean? It means the entire spaceship is limited both in terms of the distance it can travel and the time that it can consume, and it always stays inside of our universe. It never goes out. It does not create, it can never fill the full abstraction of X prime, Y prime, Z prime, T prime. The T prime can only exist within this limited square here. And that means that it can never interfere with the rest of the universe. When people talk about how you have to have a block, now this is not Einstein, and I'm saying this because Einstein did go with a block universe. But when you say this here, you don't get a block universe because you don't have the time to create it. It just can't happen. And these aren't hypothetical things. These are what actually happens with real particle experiments, real spaceships, real GPS satellites. All of them are absolutely subject to this limit. So again, this is not some hypothetical. If you have a larger frame, you launch a smaller frame, you're embedded with that frame, you're one of these circles going here, you are not going to get the ability to just extend your perception of your framework to infinity. You have the mathematical framework still, it still works. You still have Poincare symmetry. But the Poincare symmetry, now you look at it and say, oh, oops, oh, wow, it only works here. It only works within this very small, tiny area that's inside the spaceship. So I don't get the full effect with that. So that suddenly puts a whole twist in this idea of, all these mathematical frameworks. It's in computer terminology, you're creating a data structure, a virtual data structure that is infinitely large. And then you ask the question, how do I load it with actual data? That is what Einstein addressed. He said, how do I load it with actual clocks? How do I load it with actual synchronized clocks so that my definition of time has actual meaning as opposed to being an abstraction? And he came up with this idea that, it's always slower. That means one twin is going to age more slowly. He actually used microbes. He didn't use twins. So loading principle. What happens if you take this idea? Well, for one thing, and apply it to cosmology, you can kiss the idea of a single uniform spacetime goodbye, because that ain't what's happening. If you attach time to matter in this fashion, two clocks, and again, it's weird because I'm emphasizing this was Einstein's idea. Yes, he went to the curved spacetime later, but in 1911, this is the method that he used to drive a very real experimental prediction. And that method that he derived leads to this. You get spacetime that is attached to the clocks. You have all these different little circles that are going around there. The light cones can never be violated. This is precious to Einstein. If you want to conserve the definition of speed of light, you have to do this. You can't get the loading to exceed the speed of light, so you can never instantiate outside of your light cone. That's a very different way of looking at space-time. It literally is a fractal structure for space-time with limitations attached to the clocks that you can instantiate it with. The idea is that if you can't put a clock there and it's just empty space, genuinely empty space, there's no question. There's nothing you can measure at that point. You have to have energy of some sort in that space. You have flat space does not have energy. You wind up with a universe that looks like this, and this is I find it intriguing. I think people should generally find it intriguing. It turns out there has to be a single universal definition of space-time that does count as the distinguished frame. That would be the one at which everything started. The first universal bubble. I have I forget. I can't even see my own title up here because of this. I've got some interfering blocks here. But you have this initial kind of the cosmic microwave background is a very good approximation of it. And that actually defines how fast you can change. It says you really do have a limit. You can't get, just like I showed in that earlier diagram where you can't get outside of that square. You can't get outside of this thing. If you're a computer scientist, you will recognize this as virtual machines. You have your actual computer down here, and then you have virtual instantiations, which are a more limited set of the data structure, in which you're filling up just a part of it, maybe a very huge part, an entire galaxy. But you fill that up and you define it there, but it's still bound rigidly by the constraints of the other one. The time here may seem slower, but it's not going to extend beyond that. The definitions of how things look in distant parts are going to be controlled by this block, not by that block. And it goes all the way down to spaceship level. And actually, it goes all the way down to the particle level, which is another way where it gets very interesting for particle physics. One of the things I want to point out with this, I just made the statement, says that, how often have you seen the statement that everything is relative? So everybody else is slower outside of a spaceship, and everybody sees the spaceship as being slower. Now, there's no way to get around this. The statement is false. Why? Because you have blue shift. What is blue shift? Blue shift is light waves circulating faster than were before. Oops, that's a clock. You can't have blue shift without having clocks. And if you have the clocks at the front of the spaceship, where they look like the blue shift is saying that the clocks run faster, if you image an actual clock at the destination, not only will the light seem bluer, the clock will move faster. You will not see time dilation in that clock. You will see that clock, in this particular case, 3.732 times faster than the clocks in your ship. So anybody who tells you that everything is relative in all directions outside of a spaceship, it's just not what happens. What actually happens is you get a gradient. So you get faster clocks here, you get slower clocks in behind because you're running away from the light. So the frequency is slower, and you wind up seeing the clocks, observing those as being slower. So it's important to emphasize this, because this goes right back to the thing about how do you get rid of the twin paradox. The first step is to realize that when the guy in the spaceship looks towards Andromeda and he sees the clocks running 3.732 times faster, is that an illusion? No, it's not an illusion. That's what he actually sees when he gets there. It is a real measurement of the real time that we will get when he actually touches the clocks at the far side. There's nothing unreal about it. It's a very firm definition of where he's going. So important clarification. I know it's very popular to say, like, oh yeah, no, everything is the same. No, it's not. And you can find the math that gets into this. It's out there, and it's been used in some of the astronomical paradoxes. I remember I drive this equation. The equation is relevant as I drive to my own. I was very surprised to find out that it was used in the past on cosmic jets because they were encountering the same problem. So it's interesting to see the connection. Loading principle in quantum mechanics. if you're a multi-world person, you're not going to like this. Okay, light cones are wave boundaries. So kick the idea of a universal wave function out the door. Yes, am I assuming physical reality means something? Yeah, it's because experimentally, I'm not sure what else to do. I mean, we're sitting here talking now. I can make myself an abstraction, say I'm not really talking here now. I'm, you can go just all sorts of Zen ways if you want to, but let's stick with the idea of what do we actually observe? First thing you observe is there's no such thing as a quantum wave function that is not bound by its light cone. Every observed quantum wave function we've ever seen is observed by the origination of the light cone for that wave function. So does it go to infinity? No, it does not. Because like it or not, we don't see its wave function outside of that cone. You will not see the particle outside of that cone. You will not be influenced by the particle outside of that cone. Even entanglement, people think, well, what about entanglement? No, entanglement doesn't change anything at the remote site. It changes your result, not the same thing. So this is a strict boundary right there. So right there, anything that talks about a universal wave function is just not what we see experimentally, because when you have a classical observation, that particle ceases to exist in any other region. Even if it's a photon that was covering half the universe before you looked at it, once you did that observation, has no impact. It's gone. It is now part of the light cone. So what does this do on some parts of quantum mechanics? Like I say, if you're many worlds, sorry, this is, I always wonder, so why do I have such a reflexive dismissal of many worlds when so many people think it's beautiful mathematically? It's really quite simple. Is Everett just thought that if you split a quantum event, you immediately get two universes. Now, if you look back at what I just said, say, yeah, maybe let's follow up on that. So you get a split of the universes. How long does it take the light cone of the change you made to propagate to the rest of the universe? Everett never considered anything like that. He was so caught up in the abstraction and the math that he never even considered the fact that we never, ever observe that kind of interaction, which would violate the speed of light. We don't see it experimentally. It doesn't happen. The light cone for the event, when it splits, just propagates like any other event. So you get this split. You can talk about it being a split in universes, but even if you do, it's going to propagate out. So how long does it take? Well, I did one calculation once, is so many times the length of the universe when you put everything together and consider the wave factors, that it's a non-statement. It just doesn't go anywhere. So the basic premise in which Everett just glommed on to the Hilbert space definition and paid no attention to the actual physics, which Hilbert spaces can tempt you to do that. It doesn't work. Not if you embed it in actual speed of light limited reality that we observe. So you don't get universal wave functions with it. You get the same restrictions. I made that. But more importantly, here's an interesting, to me, it's a fascinating impact. Hilbert spaces are a fantastic model for quantum state tracking. So what happens if you apply this to it? What happens is the Hilbert space is no longer the most fundamental representation. And here's complete heresy. The fundamental representation is the light cone. You have to go back to the Einsteinian universe in which you can't propagate faster than the speed of light. And when you do that, most of the Hilbert space gets discarded. The Hilbert space just simply doesn't apply. And this is the same mistake that Everett made. You're talking about states that cannot exist because they would take an infinite amount of time or almost infinite amount of time to create, because states have to have an origin also. And if they have to have an origin, they have to have a light cone around them. You have a light cone around them, you have finite limits on how fast they can propagate. So in terms of math, I don't view that as a negative. I view that as like, wow, you could have a whole discipline of exploring Hilbert spaces from a constraint-based relationship with the three-dimensional space light cone and the definition of times in those light cones, which can be multi-level. So far from discarding it, it just says that no, the Hilbert spaces have levels of complexity that we have not explored yet, and that we really should try to explore them. And we probably get some very interesting results if we do. Okay, and I end with quick comments on LLM technologies, which is, I think we've already covered. I think we covered all of this, except that we are missing, and I think we covered even that, missing some bit of critical physics for how we do low power cognition. Is it probably quantity related? Probably. But the point is that we don't know it. You can ask that question and people say like, I don't know how that little jumping spider does so much computation so efficiently. And it tells us something right there, that we don't really have a good grasp on it yet. Summary. Einstein's loading principle, and as I say, this is, to me, it's just an opportunity. The way this man would think about things is just amazing. Again, you have to factor in the era in which he did this, and the idea of making a distinction between the mathematical abstraction and the loading of that abstraction with actual clocks was something he came up with that was way, way beyond that time. That's an easier concept to talk about now. It's an easier concept sort of to talk about 50 years later. But really, that kind of thinking was like a century ahead of time in terms of making a distinction between the mathematical structure, the data structure, and the loading of that data structure. So I won't try to get into the LLM stuff. We've covered that plenty, except to make that final point again, is we need to understand this low energy physics a lot better. And with that, I will wrap it up.
I see William has a question. Can you ask online?
Do you want me to type in the question or to just state the question verbally?
Or you can say the question online.
Okay, great. Um, well, yeah, two quick questions. I'm not sure if people are aware right now, but there's actually a bill in Congress, and I'm not sure what really inspired this. Um, Certainly some out of the box thinking, but there's a bill in Congress to freeze everything at the current daylight saving time and push this power to have daylight saving time out to the states individually. So our world could start to get very complicated. The next time we go back to we could be going back to daylight saving time. And the other comment I'll make is that I'm a person who's been affected in life by seeing women get hurt, primarily my mother with my biological father, and it infuriated me at the age of 2. And so I've always been a big defender of women. And in his later years with biographies, detailed biographies about Einstein, did not paint a pretty picture of how he treated women, particularly the 2 different women that he was married to. And he was kind of known as a male sex idol of his day. Women just flocked around him because he was so smart and everything. But yeah, I take Einstein with a grain of salt. As a person, as a scientist and engineer myself, I admire his ideas, and I know that he changed the world. But I'm not a big admirer of anybody that mistreats women.
William, I would add to that Feynman, if anything, was even worse. Although he did balance out. I think he balanced out in his later years and became a good father to his. He apparently was a good father to his kids. And Einstein, I don't think was ever a good father to his kids, and he treated his wives terribly. So in both of those figures, anytime I make a comment about their minds and how they analyze physics, I agree with you fully that there's an important qualifier there. These guys were jerks on these issues, and we see plenty of that going on today. If we can't start respecting people for who they are as people and stop making gender distinctions between whether you're allowed to think or not is one of the stupidest ones imaginable, and yet still carries over and is used as a self-propagating excuse. You say, well, so we don't let women win Nobel Prizes usually, so obviously they're not good at winning Nobel Prizes. Well, that's about as circular an argument as you can get. And you look at the DNA story and the double helix and how the terrible crime that was done to the lady who actually did the work and really did the crystallography work. It's there's been some improvements, but it's also been tracking in the back direction. And I just hate this. I mean, it's just my daughter and my granddaughters. I've got, a couple granddaughters that are just the idea of a world in which people can keep them from being what they want to do just infuriates me. And fortunately, I got really good parents who are very good at seeing the potential. Their other grandmother is a CEO of a large company. I love that. And the smaller one takes after her grandmother. And I think that's the greatest thing. So we need to stop doing this to each other. And we can admire the intellect. I admire Michael Jackson's, I like Michael Jackson music. I wouldn't be, really, as a person. Oh gosh, there's so many examples. And it's so unfortunate. Maxwell, I believe, was a good dude. So I'll try to give a counterexample. As far as I know from Maxwell, he was a good person. He died very young, and that's so unfortunate because he was a brilliant person. So yeah, good point. Questions, anyone?
Just comment there.
Cateno, I can't hear you.
I said just a short comment about what William just said. It's not excusing anybody, but I've heard that Einstein, although not officially proven, that had some people think that had some symptoms of autism or Asperger's, and that can affect his social behavior. So it is nature, some of greatest scientists and people who have contributed for the humanity knowledge, they were autistic, and they social integrations was not as desired as we wished.
Catena, I can agree with the point that autism makes it more difficult to understand social relationships, but I will also point out autism does not affect your ability to make ethical choices. If you're autistic, you can still understand that I'm hurting someone or I'm not hurting someone, except for an extremely severe case of autism where they literally just disconnected from reality. So it makes it harder, I think. But a lot of Einstein's behavior is just what he chose to do. He didn't have to make those choices. He didn't have to make some of those choices, and he may have not. I think he was sufficiently disconnected. He had trouble um, seeing people as important. Maybe that would be a way. Maybe that's what you're getting at. If so many forms of autism, it's hard to recognize the importance of other people. You just treat them as an abstraction, and yeah, that can lead to damage that you didn't even intend. But we all have to strive to do better, and if we have handicaps in that, um, we can do better. We can do better. And especially in the world right now where so many people are just saying, hey, I'm going to do whatever I want to. No, that doesn't work in the long run. That doesn't work for anybody. Even those people who are doing that, because they wind up constructing their own collapse. So,
But
other
back on
questions?
the question of AI and intelligence, sometimes I wonder that we have problems, as humans, in what we define certain concepts, like definition of consciousness, definition of intelligence. Sometimes I feel these concepts are kind of spectrum rather than a single point definition. So if we start thinking in terms of spectrum, in terms of range, like autism almost like we all are autistic to some extent within the spectrum, some more than others. So when we define in concepts like intelligence and consciousness maybe within this spectrum range, and also when we've been so critical about LLMs because of their stochastic nature, but we also need to remember that our own brains, our neurons operate under stochastic principles. So the question of AI and intelligence it can be more than stochastic, maybe also involving the way how we have incorporate logic within the AI, logic, the intuition, deductions, inductions, and the reduction ad absurdum ways of thinking. If in the future we'll incorporate these logical structures within AI, maybe that it will approach our kind of intelligence.
Good points. Good points. Joe, you have your hand up?
First of all, this is an outstanding discussion. I mean, excellent. My question is this. I'm watching what's going on with Elon Musk and how he's coordinating the various organizations and running the common block AI across his companies. Now, that could be a plus and it could be a minus. So I want to get your opinion because if we allow the integration of what we feel is an intelligent AI to be the ultimate intelligent AI, whether it integrates with a neural link and SpaceX and stuff like that, that's a lot of integration. But it's also a lot of control because
Yes.
it looks like that's what's starting to happen. And it's more wealth generated than anything, which is not necessarily a good control point. Um, I like your thoughts and anybody else if they have something on it, because I'm watching something that looks like collectively, it's going to have an enormous impact on where AI, whether it's AGI or ASI or whatever goes. Any thoughts? Thanks.
Anybody else want to give an opinion first? One comment I'll make, if you look at the history of Elon Musk, especially after the last set of elections a couple of years ago, control, 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 control. There is no other theme. This is a man who physically took over a building, illegally took over a building. It was later returned to them, trashed the building. His people were smoking pot inside the building, apparently all because he didn't like the fact they had the word peace in their title. It was just, but we're talking about, and with people, did you know that the entire CIA got fired because he used Grok to send out emails to the entire CIA to fire them? You don't hear about it much because obviously they didn't fire them, but that's the level of control freakiness that was going on at that time. Is everybody was being fired. It was being done through Grok. So I think all of us have to really push for democracy, the belief in people, the belief that we're all important, and that everybody should have an opportunity to get it. I love the idea that people can get extremely rich, but I don't like the idea that they can use that to squash other people from what they're doing. So that would be my view on it.
Thanks. There's a real
Great
good
question. Thanks.
commentary on it.
Other questions?
I got a question online from Emmett. Were any experiments conducted on time dilation by Einstein? I had read about a Haveli-Keating experiment which was closer to the theory.
I'm not sure if I caught every nuance on that, but Einstein himself, when he first predicted time dilation as a visible remark, one of the comments in that paper, which you can go and read the paper, was he didn't think it would ever be possible for people to witness time dilation personally, and which is really funny because we do that all the time now. People fly around in an airplane, and if they've got a precise clock with them, atomic clocks, these experiments have been done. People actually see the time dilation as they travel. So Einstein did not expect to be able to see time dilation. I'm sure he realized later by 1955 was when he passed. I think by that time they had enough, by that time they had plenty of information to show there was a very real effect. So I may be missing a nuance on the question about whether he had some other alternative experiment, but I'm not familiar with that.
He means Haveli-Keating experiment. Let me
How fully which?
Haveli-Keating experiment. It's on the chat.
Yeah. Okay. Let me look in the chat and see if I can. Let's see. And who is it? Who was asking this? Oh, were any experiment? Okay, I found it. Any experiments conducted on time dilation? I had the Haveli-Keating experiment. I'm just not familiar with it. I'm not familiar with that particular experiment. Sorry. Now I'll have to look it up though. Keep that as a note just to keep track of it. Any other questions?
Jordan has a question. What are your thoughts on robotics and AI, especially activity-based intelligence for ROS and the rise of physical AI?
I think we need to be really unbelievably careful about that because the technologies that we're using right now are insufficiently reliable to create a safe space for extreme levels of integration of AI robotics, at least with some of the technologies we're using right now. Again, robotics is one of the areas one of our research challenges for researchers, I remember at a meeting, it says, make a robot so a team in an isolated situation and somebody is hurt, so the robot can actually help. Because what was happening is people who had robots were actually risking their own life to protect the expensive piece of equipment. And it's the exact opposite of what should be going on with that. So my goal has always been to see, and my hope has always been that we can get robots that are genuinely helpful and can support people. What worries me right now is the same thing I've been talking about. There's insufficient recognition of the statistical randomness that occurs when you reach the end of the training of an LLM. There's some awareness of it, but it's too casual right now. So the same thing happens that the LLM casually deletes your database. Well, put that into a robot and the robot may casually delete your head. So you don't want unverified systems doing this kind of stuff. And the level of LLM technology for robotics just terrifies me. These things are not ready. They're not ready for guiding robots in real time. Now, that said, are they being used? I assume, I hope they're being used properly in some circumstances. I give the example yesterday from my old friend from high school who had a marvelous experience driving a Tesla, that they were able to go, halfway across the East Coast with no problems at all. So this can be done. This can be done. It can be done well. But specifically for LLMs, just look at all the problems that we keep popping up with. And we need to be very, very careful about letting that particular technology get in charge of any kind of dangerous equipment or system. So good question. But physical AI, I'm not against robots. I help get funding to develop robots. I see a lot of areas. Firefighting situations on naval ships. That was one of the areas we specifically looked at. Tom McKenna was one of those who pointed that out. Those things are built for humans. So a human form robot that can go in and do firefighting duty, man, that would be great. That would be excellent. And there's many places in the Fukushima reactors, same thing. The robots weren't up to it. So if we can get the robots moving, I think there's fantastic potential. And I just go back to my hesitation being that not with this tech, not yet. We need to go back to some of the more traditional ideas. And yeah, they're cumbersome, but hopefully we can. If these things don't have a good model, they shouldn't be going out into the real world. That's maybe a simpler way to put it. Most LLMs don't have any world model to speak of at all. So look at somebody like Jan LeCun, who's looking at model building. Those are technologies that might give a much more verifiable connection between robotics and AI. So again, good question. Thanks.
I have a question myself. Do you think LLM will eventually become an expert system?
It's funny. One of the reasons why this phase is so interesting for me is because I was really into expert systems. I was the advocate of expert systems. I helped put I don't know if it ever actually flew, but we developed a load shedding system for the space station for NASA. And Prolog helped us in that one. Boy, Prolog did better than some of the expert systems. So expert systems, I think, have a very good use. We use them in certain areas, but the incompleteness, they're skimming the cream off of what's good. One of the things I think was safer about the expert systems is that they acknowledged that they were just skimming the cream off of what they were doing. They didn't hallucinate as much. Although when you put in statistical fuzzy logic, some of them could hallucinate there too. So I would like to see us have more of a lot more automation of some of the knowledge that we have, so that it could help people. And my beef is always about how we're doing it. So I look at certain trends, and if it doesn't have, somebody's coming in now, that's late. If it doesn't have an understanding, comprehension, an ability to see what the world is, as opposed to just statistically answering based on what other answers were, then we need to be careful about that version of expertise. It can still be useful, but it tends to be rattier. We want solid answers. Go France and go Argentina. I haven't been tracking. Yeah, RAG does get you closer to an expert system. Yes, Ron, that's a good point. Other questions? Bill, thank you too.
I just had one final comment. We were way back earlier in the discussion, we were talking about how many qubits you need for this, that, and the other thing. Gate-based qubits are only one kind of quantum computer.
Yeah.
So there are. I've worked with neutral atom machines, which was the Q era, Aquila. They didn't actually operate their qubits in full gate.
By the way, anybody who's not familiar with Ron Shiner and his work, if you go back and look at one of the earlier videos a couple of weeks ago, be sure to go back and look at Ron's work. Some great work in quantum computing there, and I'm hopeful about where you're going with some of that. So
That would be me, Terry.
yes. No, I was talking to the other people.
Okay.
I was no, I knew that you were you. So I'm telling other people to I'm giving you a plug, Ron. I'm giving you a plug.
Thank you.
So if everybody was, although if you need to consult yourself, you probably should. So that's funny.
Well, but basically, they exhibit this phenomena where because you can move the atoms around to whatever pattern you want in the vacuum, the whole system seems to have this understanding of the distance between atoms, and that can be leveraged for all sorts of algorithms. So maybe that might be the scenario in which instead of using gate-based qubits, we use analog qubits to see if we can actually model a neuron. So I just wanted to throw that out.
That's which was that work again? Because that is interesting work. I think anywhere where it gets more analog has potential to access a lot of computation.
Neutral atom machines like the
Neutral
Q
atom
era
machines.
Aquila, which is a 256 qubit machine, but again, they don't operate in gate-based mode. They operate in what they call analog mode. Although they claim they've been working on gate-based mode. So they'll get that solved at some point, but the fact that type of quantum qubit can hopefully be operated in either mode gives it much more range. So,
that's interesting.
Yeah, maybe the analog mode would be more appropriate for modeling neurons. I got to think about this. So.
I think the trouble with the analog mode is our brains just aren't wired to understand that well. And I think we just reflexively kind of veer away from it because it makes us uncomfortable. But I also think I really do think there's a lot of potential in coming out with computational results that coalesce much, much faster with heavily analog as opposed to heavily digital. Heavily digital, again, is the Aristotelian bias. We want everything to be a precise decision, and then we just let a little bit of quantum leak through. So, if you're modeling very complex situations with very complex models, why not let the entire model kind of analog style fit together like our enzymes and proteins do? Because they sure do a good job of it. They figure out how to navigate this stuff. So maybe we ought to be taking some lessons from those. But that's interesting work. I'm intrigued to see where that goes.
Yeah, well, until a neuron fires, it's basically operating in an analog mode. Accumulating.
Can't quite hear you, Ron.
Until a neuron fires, it's basically operating in an analog mode until once it fires, it kind of like transitions to a digital threshold, and then it goes back to accumulating data, probably more sensibly in what you could understand as analog mode. So
Hmm.
could be very interesting. I have to think about it.
One of the things that intrigues me about enzymic biomolecules, which again I think are the experts at doing this stuff efficiently, is they come to a final result, but it's not so much a binary result as the result itself is very complex. So you get two molecules, the enzymes, they fit together in a very complicated way. So they have an analog processing with a result that does wind up being a specific result, but it's not so much a decision as a reconciliation of a whole bunch of different things into one final package. And boy, every time I look at how cells work, it just boggles my mind. How are they doing all that? How seriously, how are they doing all that? Watch one of the animations sometime about the synthesis of proteins and all the steps and all the corrections. This is what Hopfield addressed some in his 1974 papers. How do they do this? Because we see it and we pretend we understand it, but we really don't. So
It's
that's
still the miracle of life.
still the miracle of life, and I think there's potential research potential there that we just have not fully explored yet. So it's funny, quantum computing, I've gone from highly enthusiastic to like very disappointed, mostly because of the Deutsch model. That's a mini worlds model. It just kind of like, doc, it just didn't work. And then people pretended it was something else. But then I went back, and now I'm just the opposite direction. I'm going like, I think there's a lot of potential in this. I think the world's trying to teach us something. It's just let's get away from the mini worlds Deutsch model, because they tried it. They tried it for decades. It didn't really go much of anywhere. So let's stop pretending there are other universes, throwing in computers just for our benefit. I don't think that's experimentally beneficial. Let's stick with our universe and see how is it doing that. How is it getting all those things together. So we'll see. Fascinating area. Any other questions? Going once.
By the way, are you interested to talk about expert systems?
In which one?
Expert systems. That's my
Expert
favorite. Are you interested to present something about expert systems in the
expert
future?
systems. I could present. It's kind of a dated technology at this point. Let me think on that one a little bit because it's sufficiently out of date. I'd have to think on it a little bit, but
Really, you think expert systems are outdated?
for me they are. it's 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 a been there, done that thing. Um, uh, uh, yeah, let me think on that a little bit. Let me think on that a little bit.
Sure, it's my favorite.
Oh, so well, uh, let's talk about that. I think it's a good chance I'll do it, but I'd like to talk a little more. So,
Thank you.
okay. Anyone else? I say Ron said, Ron, you meant that about expert systems, right?
Correct.
Okay. Yeah, at some point, Helen, well, I wouldn't mind diving back into that. I'd love to see where that technology is going because, like I say, that was my world for a while. So yeah, we'll do one on expert system. That'd be an interesting topic. So
Yeah, it seems that people talk about LLM more than expert systems, but I just searched online. They're two different things.
well, and expert systems cover a surprising amount of the same turf, but at much lower cost. So there's it's interesting to see that interaction between them, and it might be interesting to see what you could do. Oh boy, I'm not sure what you could do with a modern expert system technology applied with modern databases and modern computational power. That might be really interesting because hardware limitations absolutely were a factor back when I was, thoroughly embedded in that world. Oh gosh, so just trying to find an engine that didn't totally destroy our computers was a problem, which is why I went to a version of Prolog that ironically turned out to be faster than the supposedly expert system shells. So yeah, okay, that would be a fun topic. we'll do that. Anything else? Helen is best as always. Yes, Helen, thank you for these presentations.
If we can talk about expert systems or some other AI subjects, that'd be great. How about robotics, automated reasoning?
Those could be topics. Those could be topics too. Yeah, robotics. Yeah, robotics and all of these are interesting topics. With I've lost track of where the latest in some of the robotics was. I used to be right on top of that, but it's been a while. I intentionally avoided the area for some years. So, any other questions? If not, maybe we're about at a wrap here.
Yeah, sure. The last comment is awesome discussion today from Ron.
Oh, thank you, Ron.
Yes.
And thank you again for that presentation. I really liked your presentation a couple of weeks ago, which is why I was plugging it. So that's good stuff. So, well, thanks everybody, and it's good to see everybody again.
Thank you.